Backyard Professor Math videos. It's a beautiful day today, and we're kicking butt with practicing our algebra equations based on what we've learned so far. We have a lot of properties that we still want to investigate and learn. However, we're making great progress. Pat yourselves on the back. We're going to look again at inverse operations, and we're going to do some basic practice to make sure that we have this down pat, because the basis of all of our solving and calculating is this. This will show us the relationships of different operations on numbers. A very important concept. 7 plus 5, we're told, is 12. Do you believe that? I do. Now, this is essentially saying the same thing as 7 equals 12 subtract 5. These two statements are equivalent. One is addition, 7 plus 5 is 12. The other one is subtraction, 12 minus 5 is 7. It's an inverse operation. This subtracts, or this adds, this subtracts, and it's an inverse. In general terms, n plus 5 equals 12, and therefore n equals 12 subtract 5. That's how they would write that algebraically here. Now, let's use this form to see how we can calculate equations. We're given x plus 8 equals 31. How do we solve for x? We isolate x. How do we isolate x? Someone's come along and added 8 to my variable. I want my variable alone. How do I get rid of an added 8? I subtract 8. But what I do to this side, I have to do the exact same thing to this side of the equals. It has to stay balanced. So this becomes x plus 8 minus 8 equals 31 minus 8. You can see this is plus, and now we're turning this plus into subtraction just exactly like this. We are reversing the operation. That's interesting to see that, right? So this becomes x is isolated because the 8's cancel. 8 minus 8 is 0, and you don't have to write the 0. So this x equals 31 minus 8. Isn't that interesting? Which is 23. Let's do another one. Y minus 8, y minus 8 equals 50. Someone's come along and have taken 8 away from my y. I don't want that. I want my y alone. So how do I undo the subtraction? I add to it. What I add to here, I add to there. Y minus 8 plus 8 equals 50 plus 8. The 8, negative 8 and 8 is simply 0. I don't have to write 0. It doesn't mean anything. So y equals 50 plus 8 is 58. That's how you do that one. Let's do another one. Z plus 21 equals 23. Someone came and added 21 to my z. I don't want that. I want the z alone, so subtract 21 from this side and this side. Z plus 21 minus 21 equals 23 minus 21. So z equals 23 minus 21 is 2. And that's how you do these kind of inverse operation equations that give us a chance to find the value of the variable. Okay, I've got those. Now, we have the same idea with 4 times 7 equals 28. This also means that 4 equals 28 divided by 7. 7 goes into 28 4 times. So we have a multiplication here, but we have a division here. Multiplication and division are inverse operations on, or in, an equation, I should say. So let's do a little bit of practice here. 3r equals 60, we are told. Now, a coefficient next to a variable means they're multiplied. So this is 3 times r equals 60. Someone came and multiplied 3 to my r, but I don't want that. I want my r alone. How do I get rid of the 3? I divide, because it has been multiplied to my r. So this 3r equals 60. I divide by 3 here, and I divide by 3 here. I didn't write those equals very good. The 3's cancel, so that the r equals 60 divided by 3. 3 goes into 60 20 times. So r becomes 20. I got that answer through dividing the multiplied coefficient to my variable, right? By dividing it, I isolated the variable, right? Let's do another one. Let's say f divided by 9 equals 72. Someone came along and divided my variable f by 9. I don't want it divided, I want it isolated. The only way to do this is to do the inverse operation of division, which is multiplication. We multiply both sides by 9 because it will get rid of the 9. So this is f divided by 9 times 9 equals 72 times 9. I'm writing it out this way so that you can see what I'm doing, right? The 9's cancel, leaving the f all by itself. F equals 72 times 9, which is 648. And 648 divided by 9 is 72. So you can see how this works with division and multiplication also, can't you? I think I had one more. Yeah, I did. 7a equals 35. I want a alone. So I divide by 7 because it's multiplied 7 times a. If I divide by 7 on this side, I divide by 7 on this side. Therefore, a equals 5. It's that simple. D 6 equals 54. I don't want the 6 there. I want to divide by the 6. If I divide by the 6 here, I divide by the 6 here. The 6's cancel on that side, so D equals, what's 6 into 54? 9, right? You can do this until you get used to doing the operations. And it's very helpful to do so because you want to get used to seeing them and you want to get your practice in multiplying, dividing, adding, and subtracting too. 2n plus 19 equals 25. Now here we have a little bit more complex equation. Not only has someone multiplied my n by 2, they've also had the audacity to add 19 to it. I don't want that done to my n though. How do I isolate n? The first step is get rid of that 19 And if you subtract 19 to this side, you subtract 19 from this side, right? Positive 19 minus 19 is 0, so this leaves 2n equals 25 minus 19. So 2n equals 6. But I still have it multiplied by 2, and I need n alone. How do I get rid of a multiplication? I divide. What do I divide by? The same number on this side and this side, because I want to get rid of that 2, I divide by 2. If I divide here, I have to divide there. 2 goes into 6 3 times. 3 times is 3 is the answer to n. Now when you plug 3 back into n, you get 2 times 3 plus 19. 6 plus 19 does indeed equal 25. So you know you got the right solution. It's kind of fun to see how that works, isn't it? It's really cool to do this kind of practice until you can do it in your sleep. You're going to want to, I promise. Okay, let me see here. Let's say we have t, plus 3 is greater than 28. Now, my t is my variable. I want it alone. I want it alone. Someone has come and added 3 to it. So how do I get my t alone? I subtract 3, right? T plus 3 minus 3 is greater than 28 minus 3. If I subtract 3 on this side of that equation, then I have to do it on this side. The 3's will cancel. 3 minus 3 is 0, leaving me my t all by myself, and it simply says t is greater than 25. So the solution to this equation, t plus 3 is greater than 28, is all of the numbers greater than 25, all the way out to infinity. That's how it works. It's that easy. It's not difficult at all. Let's do another one. Let's say 3t is less than or equal to 18. Someone came along and multiplied a 3 to my t. I don't want that. So I have to divide by both sides. Divide by 3, divide by 3. That says t is less than or equal to, 3 goes into 18 how many times? 6. So the solution to this equation is t is every number including 6, because it's less than or equal to. It's every number less than or equal to 6. Let's do another one. (3a) plus 9 equals 30. Again, someone has come along and they've added 9 and they've also multiplied it by 3. First, get rid of the 9 by subtracting 9 from both sides. So 3a equals 30 minus 9. So 3a equals 21. Right? Now we have to divide by 3 to get the a by itself, because 3 has been multiplied to the a. So we divide it by 3. We divide this side by 3. A equals 3 into 21 is 7. It's that simple. Do these until you're completely familiar with how to do the equations, and it's a piece of cake. I've done that one also. How much time do I have? Okay, I've still got a few more minutes. Let's keep going then. V plus 8 is 30. So V equals 30 minus 8. V equals 22. You see how that works? Piece of cake. W minus 9 equals 8. I have to add 9 to both sides to isolate W. So W equals 8 plus 9. So W equals 17. Piece of cake, right? If we have Z plus 4 equals 4, I want Z alone, I have to subtract 4 from both sides. Z equals 4 subtract 4, Z equals 0. That makes sense? It's a piece of cake. M minus 19 equals negative 6. To isolate M, I have to add both sides. I have to add 19 to both sides. So M equals negative 6 plus 19. 19 and 6. 19 is the bigger number, and it's positive, but we're going to take away 6 because a negative, if you flip this around, this is positive 19 minus 6. You see that? We're just taking this and putting it there, and we're taking this and putting it there, so that this is 19 minus 6, which is equal to 13. So M equals 13. And it's true. When you plug 13 back into this, 13 minus 19 is negative 6. You can see that, right? Lots and lots of practice. We practice now, we sharpen our minds, we prepare ourselves for the later mathematics, and we zippity-doo-dah through all of this incredibly easy. C plus 18 equals negative 10. We got to get rid of the 18 by subtracting it on both sides. So C equals negative 10 minus 18. When we have a negative minus a number, we turn the subtraction to an addition, so this becomes negative 10 plus minus negative 18. So C equals negative 28. And you can see that because negative 28 plus 18 equals negative 10. So it works out. You can see that's how that works. X minus 80, X minus 80 equals 50. X equals 50 plus 80. X equals 130. You can see that. We simply added 80 to both sides. Negative 80 and positive 80 isolates the X. Right? D plus 60 equals 14. We have to subtract 60 from both sides to isolate D. It equals 14 minus 60. A subtraction is a plus negative. Negative 60. 60 is the bigger number, so the answer is going to be negative. It's going to be negative 46. R minus 18 equals negative 200. We have to add 18 to both sides to isolate R. R equals negative 200 plus 18, which equals, R equals a negative, what is that, 1, I didn't write the answer, negative 182. R is a negative 182 for that. So you can see by practicing this, you can get very fast, very good with it, and you learn how to manipulate algebraically all kinds of equations. It doesn't matter if they throw fractions at you. It doesn't matter if they throw exponents at you. You can continually do this. 8 plus f equals -3. We have to subtract 8 from both sides. So f equals -3 minus 8. That's a -3 plus -8, which equals -11. Right? 16 minus n equals -10. We have to, now on this one, I'm going to add n to this. So I'm going to isolate 16 equals -10 plus n, and now I'm gonna add 10 to this side and this side also. This is the same as n minus 10. So if I add 10 to this side, I have to add 10 to this side, and n equals 26. And you can see that because 16 minus 26 is -10. You're subtracting a bigger number from a smaller one. So you're going into negative territory. You see, when you practice consistently, you really get good at this, hopefully, equals -9. What happens if 21 plus g is -9? We have to subtract 21 from both of them to isolate g. So this is -9 minus a 21. -9 is the same as plus a -21, and a negative plus a negative is a bigger negative. You realize that? A negative and you add more negative is more negative. This isn't multiplying. If you were multiplying this, the negative times the negative is the positive, but we're adding. So this is -30. And you can see that. -30. What 21 plus a -30 would be an equal -9. One more and then we'll call it good for the day. We're absolutely kicking derriere in practicing equations. Very necessary to do. If you're skipping these videos of practice, you're cheating yourselves. P plus 164 equals 299. Piece of cake. It doesn't matter how big the numbers get, the operation remains the same. We have to isolate P, subtracting 164 from both sides. So P equals 299 minus a 164, and that equals 531. That equals 135. And 135 and 164, 9, 6, and 3 is 9, and 2, it does equal 299, so you know you got the right answer. The idea here is familiarization. The idea here is to give us the ability to know what to do when we see an equation. Where do I start? We now know how to start equations for solving. So, thanks for watching my videos. Happy calculating. Have a great life. And I will see you in the next video.